Hey everybody, it's Mr. Mott. What we're going to do is go through a little demonstration about intermolecular forces. So I've got it as a cup here, and I filled it kind of right to the top with water. And we're going to start adding a bunch of pennies into it. And what we want to pay attention to is what's happening at the surface. So when we think about intermolecular forces, you can almost think about it like a handshake between molecules. And the strength of that handshake, how strong it is going to determine all sorts of properties about that particular substance, in this case water. And so intermolecular forces can determine lots and lots of things. They can determine like boiling point, they can determine how quickly something evaporates, all sorts of different properties. And one of those properties is surface tension. So the surface tension is a force at the surface of a liquid, and it's going to determine, in this case with water, it's going to determine the fact that when we add a whole bunch of pennies, what we can notice is that at the surface of our liquid, it's starting to kind of form kind of a mushroom shape. And what that shows us is that those intermolecular forces, those hydrogen bonds that water has, are very, very strong. Because as the level of the liquid rises up, those strength of those handshakes, those intermolecular forces, allow the water to form this mushroom or dome shape without overflowing. I'm going to keep adding until it overflows, and at the end I'll dump out however many pennies that we have, kind of show you how many pennies we are able to fit in here. It's going to be quite a lot. Some of the other instances where you might see something else happening is if you wax a car, you'll notice that water will bead up and form these circular spherical shapes. That's also due to the hydrogen bonding in water, how strong it is, that surface tension. Whereas other liquids, like mineral spirits or things like that you might encounter in like a workshop, they're just going to evaporate and they're not going to form a set shape. Still going, forming quite a dome shape there. I think we're getting really close to overflowing. Let's see. Nope, I think we just overflowed. All right. Now, we overflowed a little bit, but we still have that dome shape that is present due to those strong hydrogen bonds. So it overflowed a little bit, but it's still then held on to the rest of them. Now, to break that surface tension, what we have to be able to do is add something that would that the water would rather sort of hold on to rather than hold on to itself. So something that the water is more attracted to than the water is attracted for itself. And so so I've got a little bit of some soap here, and see if that does it. There it is. So there's something about soap and how it's the shape of the molecule and the polarity of the molecule and how it's put together that the water is really attracted to. We know that because the water, all of a sudden when we added the soap, grabbed onto the soap rather than holding on to itself, and that's why all the water overflowed. All right, thanks for watching. Here are all the pennies that were in our cup, just as a little proof of what we did there. And thanks for watching.